All right. Well, thank you everybody for joining this month's. I don't know. I don't think it is, but I mean, I think we're fine. Thank you everybody for joining this month's Databricks user group. First off, we're going to have Fred Heller give a use case presentation. Is there a switch? Hello? I don't see like a switch or anything, but that's what I was looking for. Is it on the speaker? Turn the speaker maybe? This is turn that. Oh, there it is. Speaker's off. I turned on the speaker. I don't know if that was. Hello? Yeah, there it goes. All right, now we have a microphone. All right, without further ado, I'll hand it off to Fred.
All right, well, thank you very much for coming out.
I will say if it's full screen, it might lag. You can try it out. Otherwise, you can just go slide by slide.
Cool. Thank you very much. So please feel free to stop me at any point, ask me questions. And before we get started, let me just say thank you very much to Xorbix Technologies, Asif, and Teresa for constantly getting this group together. It is really nice to see other human beings in person and talk about something we really enjoy doing using the Databricks platform. For me, it's for machine learning, data science. And so this talk today, I want to do just a few things, give an overview of where I work. There's a little bit of context there. I want to talk a little bit about what it takes to solve business problems at an enterprise scale, because it's not always that easy to do, and there are methodologies around it that I will say lead us to using a platform like Databricks. And then I want to just fly through a bunch of use cases, stuff we built, not just me that built them, but a team of very talented people. Hey, let's try this. There we go. Now, all right. Okay, so using technology is super fun. I get wrapped up in the fun of it frequently, but there's a point. It's about delivering business value. So two things converge for us: a governed and secure lakehouse, that's the data lake plus a software layer that makes that a rigorous data warehouse, and democratized data products that we can now deliver through things like Unity Catalog. All these two things converge for us into serious business value. So let me just talk a little bit about Hitachi. Hitachi is a conglomerate of over 700 global corporations that combined together make us the 8th largest technology company in the world. So frequently we will show up responding to requests for quotes from customers and find out that we're competing against our sister companies all the time. The business model is around social innovation, using technology to help people live a better life. That's the mission. Here's kind of where we live in the United States and Canada, and we also have some offshore in Costa Rica. But you can see after the pandemic, we've become very lean, only have an office in Toronto and an office in Irvine, California. The rest of us live the remote dream, which I don't think I can ever go back. We are also 100% focused Microsoft partner, as well as a Databricks partner. But when we go build things in a cloud, it's in Azure. Now, if there's an S3 bucket out there from one of our customers, no problem to go connect to it, but we only really build in Azure. Got lots of specializations, and I'm happy to say that, was that yesterday? Yeah, it was. Yesterday, we passed the AI and machine learning specialization audit, which was a relief. So now let's get back to just thinking about how are we going to solve problems. If you're in a large enough enterprise that you got some serious business problems that end with a lot of zeros around the problem area, you hopefully are working in a company that has a business strategy, right? You've got some strategic framework to operate around and maybe a data strategy. All right, now, so you've got some data on your fingertips, maybe, but let's think about over time how large institutions were solving problems. Way back to the scientific method, almost everything else in this list is flowing between a combination of the scientific method and some Eastern thought around what's been called dialectics, came out of Taoism. I'm not a philosopher, so I won't go into those details and embarrass myself. But early in the 30s, when it was time to figure out how to make a telephone system, statistical process control was kind of born at Bell Labs. That was growing once we added constrained optimization problems. You started seeing things around called management science. These were then combined with root cause analysis into total quality management, which turned out to be kind of Six Sigma. Then we got into lean and also something called systems thinking. And I'm talking specifically about Peter Senge's version of this in the text, The Fifth Discipline. And then CRISP-DM, that's cross-industry standard practice for data mining, came about. Plays well with Agile and another form of problem-solving methodology called design thinking. So we put all these things together, and the thing you need, they are all based on some form of data collection. That's how decisions are going to be informed. And what we've learned is if you can democratize access to this data, get it to the people who are doing the work where the problems are happening, you can do things like improve continuously. You can take your frontline workers and let them help solve problems for you. You know, it was the Toyota production system that was one of the first assembly lines that allowed the frontline workers to stop that assembly line and say, hey, we have a quality problem here. Before, in most Western countries, stopping the assembly line was viewed as a form of laziness. But also think about operating where the environment is changing rapidly. Oh, like, I don't know, maybe a new technology like language models pops up, and all of a sudden all of your competitors are able to process their document assets at 10 times the speed. How are you going to catch up to that? We can focus on the solutions from a user's viewpoint. And we can promote learning in an organization that allows an organization to be adaptable. So it's unfortunate sometimes people leave a company and they say, oh, we can't do that anymore. Bob and Sarah both left yesterday and we've lost that capability. So if you want to have an organization that continues to learn, how you collect your data, how you're able to leverage that data makes a big difference. All right, now let's just get into the use cases and move away from the philosophy. So I'm going to go one at a time, and my marketing people did a beautiful job on these slides. So I might have to read them with you a little bit because they look brand new to me. Let's talk about how I'm sitting at my desk one day, and I had heard about this project, and people were saying, hey, Fred, we're going to get started with the front end, the user experience design. We're going to kind of figure out what the customer's really heading for, because it was a marketing firm, and they wanted to help artists, say musicians, performance artists, manage their contracts, because they all had a lot of contracts. It's kind of the canonical disparate data problem, death by 1,000 cuts. You're an artist and you have 50 to 500 contracts. How do you know what your obligations are across all those contracts? And how do you know when you're supposed to get paid and if you're getting paid the right amount? So they were going to make a platform to share this with people, with the artists. And then all of a sudden they said, hey, you know, man, we're done. Now it's time for you to go deliver it, but you got to hurry up. You only got about 6 weeks to figure this out. This is where our partnership with Databricks kind of saved the day, because I was like, okay, here's my requirements. They want to meet the end users where they're at. Well, these people are artists, so what do? They're on their phone. They do business on their phones. So now we're going to have a mobile application that is revealing their contractual information, and not just for them, but for the record labels or the production companies that own those contracts. There's a lot of security that needs to happen. And we had to meet this very aggressive deadline because some marketing people wanted to tell a story. All right, and so they're not going to wait around and listen to a bunch of nerds saying, I need more time. And here's where Databricks really saved the day for us. We have governance out of the box. So we deploy Databricks on a virtual network with private endpoints, can do that with infrastructure as code, just running a bicep or a Terraform script. And the lawyers for the marketing firm were extremely concerned at this point about what are you going to do with all these contracts. Once we could show them that we could easily govern that data, and the marketing firm could see that a super user could do this by just writing SQL scripts, I was off the hook and nobody was complaining to me anymore. So thank you very much, Databricks. We had centralized access control and the unified platform, because you have different people collecting the data, then solving the challenge of how do we read a contract excuse me, automatically, and making sure we only get the information that we need. We've also found that, especially with a vector database, we can get the lowest total cost of ownership by using the Databricks platform. And we were able to connect to a variety of enterprise systems. And so you've got data scientists working in there with application developers. They have very different mindsets. So the data scientist can say, hey, I'm going to give you a secure endpoint. And the application developers would be happy that they did not have to learn anything else about data science. And we were able to pull this off in under the 6 weeks. So we made it. And I just kind of want to share a little bit about what does this project timeline look like. So weeks, all the way at the first 11 weeks, I started hearing about the project somewhere in here. I heard about it back here. Hey, we're going to need your help. Then I didn't hear anything, and pretty busy. Everybody's been pretty busy with the new toys on the market. So around here, like week 11, oh yeah, we need these people to come in, and you better hurry up. The only raining on the parade I did was, hey, let's make sure we get some infrastructure in there that is secure. So we had secure landing zone deployed from our infrastructure team. And then the data science work and the serving, all of it, into production happened in 6 weeks. And I was absolutely relieved. All right, so let's move on to the next thing I want to talk about. Quite a favorite of mine is predictive maintenance. 2 examples. I like this slide because it's 2 for the price of 1. I've got medical devices distributed across the globe at hospitals, and I've got a lumber mill. Basically the same kind of application setup, same set of code, solved with both problems. It's classifying for anomaly detection, more or less. What's going to break and when. For the hospitals, this problem was, you know, when the machines go down, the surgery centers back up, the emergency rooms back up, and what this means for a hospital is a loss of revenue. Now, for the lumber mill, their problem was a grader, laser-based machine that would grade the wood. When these lasers get out of whack, they're grading boards that are top A-grade boards. They were grading them at C grade, which right there at that point in their manufacturing process, that's top line revenue just gone. So in both cases, it's about ensuring profitability. Our solution starts out, let's deploy a lakehouse architecture. Number 1, for both cases, we can use sort of simple survival models that the actuaries use to price our life insurance, and traditional machine learning classifiers, random forest, and XGBoost actually were the culprits there. And one thing that's been very helpful and helps our employees that do data science have a good day at work is the integration with ML Flow that Databricks has been able to carry on. And so in both cases, we've been able to get the devices on the left-hand side. This is what the business user sees. This is the technical service team for the device manufacturer. And you can see there's some geography here because it wasn't just like, hey, you know, this gear and this device is going to break in 3 weeks. Things break, and when they would send a technician out to fix that problem, they would also scan for issues in nearby hospitals. So if we're going to fly a technician from New Jersey all the way out to Oklahoma, let's go visit 5 or 6 hospitals in Oklahoma. And we were able to direct the technical service team to have a list of parts with them that we might need. Things like that. And that's what was the saving for the manufacturer of the medical devices, is they were losing their shirt sending technicians one at a time. And so now basically it's kind of like a traveling salesperson. Right? Pick up a little group all at once. Similarly with the boards, you can see there's anomalies being registered here. And we could look out and say, hey, in the next 30 minutes, go and recalibrate those lasers. And I guess here on the slide I'm saying hourly. So we would look at it was a very interesting problem around the statistics, the distribution of the grades coming out. And you could watch these distributions changing in time, and kind of a little bit of like a hypothesis test going on in the background, and alerting the team to go and do the upgrade on the lasers. And then my next case study, how am I doing on time, Teresa? Okay, cool. Automobile manufacturing, van sidewalls coming in ocean containers, and they were showing up rusted. And I was really skeptical that, hey, why are we going to solve this? How are we going to solve this with machine learning? Are you sure people can't just find a common sense way to package these things up better? And the company said, look, we already cover them with grease. And we believe, the subject matter experts said, we believe that there's something going on with moisture in the air. When there's been a lot of rain, these ocean containers are crappy, and there's holes in them, and the trucks are spraying water up in there, and that's what might be causing the rust. So we listened to the subject matter experts, and I did not give them a lecture about common sense, which probably kept them as a customer. But we were able to look at the correlation between the arrival of rusted parts and the weather along the route, and it was strong enough to support a machine learning classifier to make the prediction about, hey, you could at least alert the factory when the ship was arriving that they were probably going to have rusted parts. So I was surprised that things worked out so well there. And I really have to say again, it was the fact that the delivery team was listening to the business experts and took what they said and made measurements about it and actually found a measurable correlation between the weather on the route and the quantity of rusted parts that came in. So here's one that was using some vision models. Here I give you a little architecture. Databricks is orchestrating everything for us. Very handy when we have a lot of disparate systems holding data. The problem was they were burning they had said they're burning 10, 15,000 hours a year. Customer service representatives struggling to take photographs from customers of their, it was a company that made conveyor belts, and they would get a photograph from a customer and they would say, hey, we bought this belt 8 years ago, and we need a new one now. And it was taking them weeks to figure out what belt it was. The vision models could bring that down and give a recommendation. So basically it's a recommendation engine to the customer service rep in a matter of minutes. So that was kind of fell in our lap so nicely. Similar purchase orders. There are expenses if there is logging in and setting up an EDI connection to a company for a supplier. Small suppliers don't want to spend that money. So they say, no, we're going to email our purchase orders to you. And we could, on the lower left, form language models using Azure Form Recognizer and Spark NLP. So it was John Snow Labs had this, and they still do. It was an excellent language processing library that would run on your Databricks clusters. And we started using that, and then over here we're able to use now document intelligence and the language models to do it much faster. Okay.
So Fred, can I just ask a question?
Please.
So the vendors who didn't want to use EDI will continue to send purchase orders through email?
Yes.
And now the solution you just showed processes it just as fast as an EDI transaction.
Pretty close.
Pretty close.
Pretty within minutes.
But it moves a manual.
Compared to hours. and a task that the employees did not want to do. Like, so we talk a lot about like ROI. I'm about to talk about ROI for language model pipelines. But often some of the biggest ROI is that the employees who have been doing this manual chore are now relieved of it and they're super happy. Oh, sorry.
People can't do a high.
Oh, sorry about that. Okay.
Sorry.
I like to walk around and wave my hand. So I was just commenting that a lot of the automated decision making that we're able to install with machine learning or artificial intelligence has more than just a top line revenue or a reduction in cost effect. You can take away extremely tedious chores that employees don't want to do anyways and help them have a better day at work. There's a huge triple bottom line there. So now another example of that, let's just start with the return on the investment for building some data processing pipelines. Here on the left-hand side, the return on the investment, we were processing requests for proposals. So I'm a firm that has built the same thing for 30 years. I've answered hundreds of thousands of these requests for proposals. I've got them stored off in some file servers, and the employees have to dig through these old examples to help create the new one. So you have here 2 full-time employees working about 3 weeks to produce the first draft of one of these responses. After the automation, it was about an hour and cost about $15 to do it with the language models in the core. Another example over here, processing documents. You had 1 full-time employee working about 2.5 hours. They could go through 50 pages and extract about 67 items. With the automation, 20 minutes and 30 cents, and you get about a 10-fold increase. 406 pages, 500 items. So you got unhappy employee who now, and the company can use that employee in a much greater capacity with this chore removed from them. And let's reveal what I'm talking about. So when we've been deploying these Gen AI pipelines, we see it coming in 3 categories. You got your chatbots. Hey, I need help, fast search, quick summaries. Then the content generation is this example with the request for proposals getting generated. And let's just talk a little bit here about responsible artificial intelligence. We're only going to commit to the first draft for a review by the human being. So even though we're using things like LLM as a judge, pipelines to get a different language model to evaluate the outcome of the first, we still want a human there at the end of the day, at this point, pressing the button saying this is okay. And then the last one, which is just, we call it document processing. It's one of the biggest areas of our implementations. I got a whole bunch of documents. They're technical. They're 300, 600 pages long. And I have human beings that are reading these documents and filling out tabular spreadsheets with this information. And oops, human error missed the fact that we had to install porcelain sinks in a 20-story building, and we missed it and put in stainless steel sinks. And boy, that hurts. That's like right there, a massive profit loss. And let's just look at across industries. It's maybe a little hard to see all the words with some of the gaps in the screens there, but more or less all of the business questions are about the same. You know, what should I do next? How can I get faster at this? How can I reduce my cycle time and capture more opportunities at the same time, right? Your agentic workflows don't need to take lunch breaks or anything like that. As long as the power plant's working and the data center's good, we're working. And these kind of pipelines are within, call it 4 to 12 weeks of manifestation for companies. Let's talk about the images now. In the construction industry, there's lots of changes happening. I've just gotten another 1,000 pages of architectural diagrams, and nobody wants to have to pore through them, and they are tough. A little bit of processing here, not much, a little OCR, and a little, or let's just call it a little bit of vision algorithms. And then that becomes the input, the features to apply a language model to as a classifier and say, hey, in this next version of the diagram, here's what's missing. And here's kind of the demo user interface. And I just want to call out with the latest improvements from Databricks and the Databricks applications. It's a game changer for your curated data assets in Unity Catalog. Delivering these kind of user interfaces now are like at your fingertips. A little bit more talking about the ROI on this. You're talking about hundreds of, well, between 50 and 100 diagrams here. Manually, you're, half an hour, even like 3.4. This is a good thing to point out. Sometimes the AI processing time is greater than the manual. When the manual time was, hey, 3.4 minutes, right? It's going to take AI a few extra minutes to chew on that. But it's always going to be about 12 minutes. And you're only paying 40 cents to get it done. So super cheap. And the reductions were huge. So maybe about 2 cents to process a page. Astounding. Often missed by, I'll say myself, and other technologists, because we're super excited about building that pipeline, right? Like not taking enough time to fill out a chart like this to make these measurements, but it's blown my mind. Here's a great picture about processing documents. These were like 600 to 1,000 pages of technical details about how to go build some structure. And then these could be, in the construction industry, it's called a submittal. There's a place here where audit control is super important. It's like submitting your finances, if you're a publicly traded company, to the Security Exchange Commission, right? Your 10Ks and 10Qs. You want to make sure the data underlying that report is really solid. Same here for these submittals, because there's a lot of money on the line at the end of the day about who's responsible if there's a problem. So having an audit trail and lineage on the data that's being extracted is super important. All right. Here, almost the same thing on the left-hand side is descriptions of parts. For an OEM manufacturer, customer comes to them and says, hey, I want you to go build this stuff for me, and it's got to be like this. Well, there's like 800 to 1,000 rows in this table. They have to apply all these rules to classify the building of those parts into their manufacturing floor structure. So you're going to make a classification into 3 categories on different criteria. We were able to apply those rules with the language models and do this classification and get reasonable accuracies and very nice F1 scores. So here is an early result. You'll see for the system feature, we were only getting an F1 score at 71%. So that told us this is where we need to make improvements, both in the prompt engineering and the LLM as a judge, parts of the pipeline. How about receipts? Employee travel and expense. I'm not paying attention to the time. How am I doing? All right. Oh, okay. And I've just been asked to figure out how to figure out if AI generated the receipt that's been submitted. So this one was really interesting. It took them it was taking the humans a long time to get down to whether or not, you know, because like 80% of the transactions from the employees were just fine. That little 20% was taking the 80% of the time of the team to process. And this was just using the multimodal features in a language model. And so you've got SAP on one side, on the very left-hand side, using some bots to extract transactions and then build them back and match the receipts to the statements. So this was taking a team of like 10 finance clerks forever to process. And you know, we hear a lot of people in the news talking about, oh my gosh, AI is going to take my job. Well, these employees were like, please take my job. I hate it. And when we gave our first like demo of our first iteration, they were like virtually hugging us. Like, I can't believe this is almost over. A little bit of extra work to, this one did not fall in our lap that easily. There was a little bit of extra work on controlling hallucinations. That was not easy. That's all I'll say. All right, I made it. So questions, happy to delve into any piece. If I didn't show a lot of architecture diagrams and technical details, but if there are questions, I would love to field them. And go ahead.
Okay, fantastic presentation. So this question is open to everyone. Like, what role does automate inference play when it is coming to this scaling any kind of system. Automated inference environments like playing your machine learning model, like train machine learning models without triggering it. So it's going to up and run.
Oh,
Yeah.
so in this case right here, how was it triggered? By the way, this is common. So you have this bot breaking up the statements coming out of SAP. So a new batch of statements lands, and you're just listening to a data lake folder. Oh, okay, we got more to process. Kick off the job. Databricks workflow spins up, processes it, sends it back out to the system.
Thank you.
Yeah.
Follow up for probably a more concise question. Let's say that beforehand you have this implementation in mind. How do you, from the get-go, architect what potentially go wrong so that you could further mitigate impacts like hallucination down the line? How do you plan that?
Help me understand. Say your question again so I can repeat it so everybody can hear it.
Whenever you're thrown into a new situation, you need to identify what set of classical machine learning that's not deep neural nets versus language models versus human automation versus what level of content, et cetera, into that kind of project management and planning. How do you go into a situation and handle that when dealing with edge cases like those things?
Okay, so we've got the edge cases, or maybe these large cases of hallucinations with language models. And I think your question is, you're thrown into a new situation, you have a new customer, end user sitting in front of you saying, hey, I've got this problem, it's taken me forever to do this stuff. I think, can you figure out a way to automate this process?
And what could potentially go wrong so I can worry about that and think about it from the get-go.
All right, and then, yeah, how do you start architecting these solutions with risk mitigation in mind? I guess there's no shortage of like help from scars of screwing things up. I'll tell you that. But here's the other thing. A surefire way, and I am sorry I did not put this slide instead. A surefire way to apply either machine learning or AI so that you're guided towards a good solution at the end of the day is to follow the human beings closely who do that work manually today. Those subject matter experts know things, and sometimes they don't know it, but they have their gut intuition. And listening carefully to how the humans do it, and trying to, at least for your first 1 or 2 sprints, your first 1 or 2 iterations, trying just to mimic what the humans do. Like, if it's going to be a machine learning thing, sometimes the human brain, right, it's a nice little neural net, it classifies things for people, and they think it's just their intuition. Oh, I can look at that board, and I know it's an A board and not a B board. Or, hey, you know, I can tell from the way this customer wrote this email that it's going to be processed by these people over here and not anybody else. And like trying to divine from that a way, and it's like, you know, those old cartoons where there's a mathematician proving something and then there's the big cloud that says magic happens here. There's a little bit of that place where you get stuck and you're like, I just need some magic to happen here. And then start hammering away on it with the AI or the machine learning tools in the simply as lazy as possible. Like, as lazy as possible. Hey, I'm not going to spend a week developing a classifier. I'm going to pull XGBoost off the shelf without any hyperparameter tuning or anything, and shove the data through it and see what happens. And then keep iterating and don't stop. I would say my team members made me put together a presentation for customers that said, if you're going to engage in true data science work, your team members need to have the soft qualities of curiosity and perseverance. Like, it's a scientific endeavor where you just have to keep beating your head against that wall until you figure it out. But every iteration you take should be teaching you something. So I guess in short, follow the humans that do it today, because they're probably doing a B+ job at least. It might just be taking them so long that it's unprofitable. And then secondly, just don't give up. Sometimes it's that thing like some of this. Oh, the hallucinations. Do not underestimate the LLM as a judge pipeline. And then chat, if you've got tabular data available, chat with SQL and bring that together in a way with the language model output. Because there's some serious grounded truth in that tabular data. Let's just say they've gone through the pain and suffering of instituting medallion architecture, where they have this silver layer that's a single source of truth. Then you can blend those together with the outputs of the language models. So it's not easy. That's a really hard part. Really hard.
I have a question specifically on this.
Yeah.
Here. Well, kind of two. The first one is easy. Are you only using the multimodal capabilities of 4.0 to get that text out, or are you using other models, like other classical models on top of that?
No, it's just language models. There's no machine learning under the hood here.
Because you spoke about, my next question going into that was about the hallucinations specific to this one.
Yeah.
Did like the LLM as a judge testing help at all with that, or how did you go about like trying to fine tune that?
No fine tuning.
Or well,
That's
not
right.
fine tuning in that sense, but like refining it.
Refining the prompts.
Yeah.
We've been amazed at how far prompt engineering is getting us down the pipeline. Like, I just maybe 4 months ago presented a solution to both Microsoft solution architects and Databricks solution architects, and there was like an internal kerfuffle over should we be fine-tuning a neural network or a language model here. And I was like, I think you nerds just want to fine-tune some stuff. And both Microsoft and Databricks said, yeah, this is classical prompt engineering right here. Don't try to make it much harder than that. Is that an answer to your question?
Yeah, I mean, specifically for like getting that better prompt, like did you use LLM as a judge? Did you make like true samples to test against?
Okay.
Yeah.
So always with these language model problems, we've learned this the hard way. Always force the end users, their subject matter experts, force them to help create a benchmark set of questions. And limit your liability to the performance on that benchmark set. Right? You get into these scenarios where let's just bring 1,000 people on the phone call and anybody can ask anything they want. Whew. Right? We're not that far along yet. But anchoring yourself to a representative set of benchmark questions, right? You don't want to make it too easy on yourself, but what the end users would call a representative set of questions.
That makes sense.
Yeah. And then the Pydantic library has been very useful in collecting the output and getting the output in a format that lends itself to automated processing downstream. And if you're wondering, this bot here, this is not a language model. It's Azure Functions. because they connect automatically to SAP. But that game's changing now too. If it's SAP in the cloud, we can go directly through Databricks, which is pretty nice.
Any other questions for Brad?
Hey, well, thank you very much for listening. It's been a pleasure to chat.
That was awesome.
Thank you very much.
Yeah. All right. Thank you again, Fred, for that great presentation. Now I'm going to find wherever my presentation went. And we're going to pivot to a more technical point of view. I mean, talking about a newer specific feature on Databricks as soon as PowerPoint will let me present this. There we go. All right, so I'm going to talk about LakeBase. It brings essentially Postgres to Databricks. So it brings transaction processing on top of the existing analytical processes that Databricks already is great at. There's a little delayed on my end. See if this pops over. See, you got it to work when you came up here. This is what I was worried about.
There you go.
You hit the bottom button. And that seems
I
to-
was using the arrow keys.
There we go. Okay, the bottom button works. All right, that's the one that works. Yeah, just a little introduction. I'm from Xorbix. I'm a certified Databricks engineer professional, and I also work full-time in Databricks, currently staffed in the insurance industry. So I work with Databricks every day. And to kind of poll everybody who's here, I kind of just want to see who actually uses Databricks. So maybe just like a raise of hands, like who works at a company that uses Databricks? All right. Who actually here uses the Databricks application regularly? All right. And to kind of pivot out of Databricks, who here interacts with like a SQL database on a regular basis? It could be Snowflake, it could be Postgres, SQL, anything that stores tabular data. All right, cool. I just kind of wanted to see where everybody was at in terms of using different things, because this is going to be all about a new database system on top of Databricks. So it's going to be kind of the in-between of analytical processing and transaction processing. So what is LakeBase in general? If my slides will ever update the screen. I'm just going to go this way for now, just to keep them going. So LakeBase is a full Postgres database on top of Databricks. I'm going to be stumbling over database and Databricks this whole presentation. It's built on top of the data lake. This all came from a purchase of a company called Neon that Databricks bought, I think like a year or so ago. They were working on essentially what this is. It's like a data lake focused Postgres version. So the idea is to separate the compute layer from the storage layer. Little under the hood of how this is done. If you know Postgres, I'm not a Postgres master, but Postgres stores all its data in pages. Those are stored on the data lake, and the compute reads those, and it has a bunch of mechanisms in place to keep the state online without having to reread that data all the time. So essentially, LakeBase, Postgres on Databricks. You get a regular database that you can deploy within Databricks. This presentation is going to be like 5 minutes long, then I'm going to hop into Databricks and start doing some commands and showing you some stuff. So some features of this are, I am just going to stay out of the full screen mode because that is just not working for me. It has easy synchronization between Postgres and Unity Catalog, so you can bring your Postgres data into Unity Catalog really easily, and vice versa. So you can bring your Unity Catalog into your Postgres database really easily. I'll be showing those two use cases off in a second. You get unified governance through Unity Catalog pre-built in. Since this is Databricks, you get UC. There's going to be auto scaling, so you can, if you have bursty workloads or you don't use this database on the weekends, it'll scale down to 0 or scale up when it needs that compute. Another cool feature that this has is what they call Databricks branching. This is mostly for a big use case. They were advertising this a lot during the Databricks conference, was for their Agentbricks framework. So essentially the idea here is you have an agent, and instead of operating on your main database, you create a branch off of that database. Your agent can work off of that branch instead of working off the main database. Keeps a little safety and a little bit more dynamicism when you're using databases with agents. In terms of current availability, this is a public preview feature. There's a handful of regions this is currently available. US East and West are the main two which we use here. There's also some Asian Pacific ones and a couple EU ones in there too. One thing that isn't out yet is the auto scaling. So currently it's just you pick a compute size and it's just at that compute size. You can change that if you want, but it's not going to auto scale for you. Use cases and benefits of this system within Databricks. I mean, just in general, the benefit of this is bringing a transaction database to Databricks. You can get those real-time needs of accessing data. So, you know, some of the examples that Fred brought up earlier, like tracking machine info and IoT data for machine, like predictive maintenance. You can store all those right into Postgres instantly. You can read them out right away. You can also use this for like an application need. So like if you have a chatbot, all the application data of that chatbot, like if you have a RAG chatbot, you can store the conversation history. You can put, maybe if you have like user preferences in Unity Catalog, you can put those in your Postgres server so that your agent can read those in real time as it needs them. There's many use cases. This is just a database, so anything you can use a normal database for, you can do this right in Databricks now. Oh, another cool use case is for AI and model serving on Databricks. There's a way to set up your model endpoint to do feature lookups for you. So if you have a huge data set of a bunch of different features and maybe they're all bound to a certain ID, you can send the endpoint an ID. Databricks will do the work for you to grab those features and do your inference and send the result back. So your endpoint doesn't need to receive all your different features. And you can do that with Postgres now. This is just a screenshot. I'll set this off in a second. This is just what it looks like in the preview screen for enabling this feature. So you've got to make sure you have, if you want to use this, you've got to make sure you enable it. And then after a few minutes, it'll turn on. You might need to refresh, and then it'll appear, and you can start using it. Before I get actually like hands-on here and into Databricks, I do want to talk about Databricks Apps, which Fred also mentioned a bit earlier, which kind of was perfect because kind of the idea of Databricks is to kind of really expedite that path to production. So now instead of, you know, maybe you need an infrastructure team to deploy servers and a database for your application, you can now do both in Databricks. You can do database and you can deploy the apps. These support a whole bunch of the modern frameworks, you know, React. You can do Python APIs using Streamlit and Dash. There is a way also if you want to do like a hybrid approach, like a Node front end with React and a Python back end. That is possible. It's in the documentation. There's a little bit of a complex setup to do that, but you can do it. If you need authentication for your apps, that's all done through Unity Catalog itself. So they kind of got a pre-built authentication mechanism with it. And again, we saw a use case earlier from Fred. There's the POC kind of UI that was made in Databricks Apps. So that's a great example here. I have a list of other examples here. You know, if you want to make a chatbot UI, you know, powered by the Genie within Databricks, you can do that. Maybe you have a bunch of pipelines and you want business users to maybe set up a couple configs and hit run or something. A lot of the use cases I like to think of are in terms of, you know, some data manipulation need that maybe to make business user ends life easier by creating a quick UI so they can do it themselves instead of having to ask to engineer teams every single time. So all in all, Databricks Apps, it really simple deployment infrastructure. It really speeds up the path to production, easy security, and everything's within the same environment. So the data you're working with and the application itself is all within Databricks. Quick wrap up slide. This is just saying basically LakeBase, Postgres, and Databricks Apps together really synergize with each other and really benefit off of the features they both bring. So you can really build a fully fledged app now with its own database, all within Databricks without having to, you know, have some other, need an infrastructure team to set some stuff up for you. So that's really all I have in terms of slides. I'm going to now be jumping over to Databricks, and I'm going to be showing you how to create a Lakebase, doing some queries on it, showing you how to query it from an external location, and syncing data between them. So let me go over to my workspace. Let me zoom this in a little bit so it's at a readable level. That's probably good. So I'm in my Databricks workspace here, normal screen. Let me first just show you where to enable this. If you have the permissions on your account, you'll have this little preview section here, right below my head. In here, this is where all the different previews are. There's always previews under here all the time. So if you want to enable LakeBase, you search up LakeBase. There it is. I already have it enabled, so I'm all good to go. But that's just where you would find it to turn it on. Now, for actually creating a database, you go to the compute screen. This is just kind of a nice UI that puts all your different compute across the platform in one place. When you have it enabled, we'll have this new LakeBase Postgres tab here. And as you can see, I already have one deployed. I deployed this earlier. It takes like 5 to 10 minutes to boot up the first time when you deploy it. So deployed it beforehand so we didn't have to wait through that. But if you wanted to create it, it's a really simple UI. And if anybody has any questions while I'm going through this, just feel free to interrupt me. All right, so to set this up, it's just, set up a name, you set up the instance size. The current options are 1, 2, 4, 8 currently, so all multiples of 2. This is all using serverless compute behind the scenes, so if you have a budget policy already set up, you can bind that during the creation screen. Pretty sure you can go back later and edit it and switch it out if you need to also. Some of the advanced settings are kind of nice, so you can set a restore window, so you can go from 2 to 35 days in the past to have a point-in-time recovery for your database. You can have high availability clusters enabled on your databases. You can have secondaries and make sure it's all able to read really fast. And then for the branching feature, that is this create from parent here. So in here, you type in the name of the database you want to copy from. So like I have the debug demo one set up already if I want to do that one. Put the name there, and then I choose what point in time I want to copy the data from. So you either can do it, from right now, from the time I hit create. I can do a specific date and time, and maybe I want to go a week in the past to copy all the data from. Or you can get a log sequence number from the actual Postgres server and use that as a point to start from too. So that's creating a database. Once you've created it, you'll go to a screen like this. This configuration screen is basically everything we just looked at, just in a view, just to kind of show it off. You get a connections detail screen. This one shows you some pre-built strings you can copy and paste into your applications. You can use PSQL, because again, this is just a Postgres database. So all Postgres tools are available. There's an extension I've used before called pgvector to store a vector database directly within Postgres. You can use that here. All the extensions are supported because, again, this is just Postgres. For authentication, this uses Unity Catalog. So like this is just a default here. This is just showing me because I'm signed in as tyler.faulkner@xorbix.com. So it's showing me that email there. But if I wanted to, I can go to like the permission screen and I can add other people and give them a Postgres role on the server. So this box up here, this is their Unity catalog, service principal, group, user, whatever it is. I can put it in here. I can assign them roles within the Postgres server within the UI. You get a metric screen. So this is like a normal screen you would see for like anything on Azure, like normal metrics. You get average transactions per second, rows per second, number of connections, storage utilization. So any kind of metric you would usually see anywhere else where you would deploy cloud resources, you can probably see it here. And then we'll come back to catalogs in a little bit, but this is how you bring data from your Postgres server into Unity Catalog. It's essentially using a foreign catalog. But they have like a pre-built button here so you can easily set it up. So before I get to that, let's actually start querying this. I click new query. This is going to bring me to what looks like a normal Databricks SQL view, but it's actually Postgres SQL, which the SQL dialect is slightly different between the two. And the way you know that you're in like the Postgres SQL version is it'll have this little badge up here in the corner that says Postgres SQL. And it just says like, this is different than Databricks SQL is basically what this is saying. And then also, normally this catalog view on the side is showing Unity Catalog, but when you're in Postgres mode, I guess is a good way to say it, you see instead all the databases and schemas that are on your Postgres server instead of in Unity Catalog. So let's start firing a few queries here. Let's create a new database. We're going to call this demo 4. As you can see, I've practiced this demo a handful of times. That's why there's demo, demo 2, demo 3. So you guys are demo 4. We're going to create a database called demo 4. And we can allow it. And you'll see the output down below, just like any other SQL command. This is just kind of an admin function, so it just says OK because it completed successfully. And now, Up here, just like in normal editor, you can see all your different catalogs, or they're called databases because we're in SQL now. And let's go to our demo for database that we just created because we're in SQL, we're not in Unity Catalog. And now let's make a schema. Let's call this demo user group. Schema, run, we created a schema, and now that automatically updates on a server. Demo user group, and now let's just create a table to kind of wrap this up. Create table, demo table, let's call it. We'll give it 2 fields. We'll give it an ID, an int type, and a comment of a varchar. And we can create that. And there it goes. So now we have a table, and let's query that table just to make sure it's not lying to us. Select star from demo table. Demo underscore table is what I called it. And I'm just going to select this one. And as we see, we should have an empty table. Perfect, exactly what I wanted. So now we have, this is interacting with the Postgres database within Databricks itself. So you can do that directly within Databricks. You're connected. You can see what server you're connected to in the top right corner. So like instead of showing your compute up here, it shows your different servers that you have. So you can switch between them if you need to. So now let's connect. Oh, I don't think I have the code available here, but I can. This is not the right demo. But before I get to that, we'll do that at the end and go back. I'll have, yeah, go ahead.
Coming to the connections, like how we are managing the connections through the Databricks to the SQL line. Do we have any flexibility of opening the ports separately? We have internal ports, we have some, but
so like it opens it uses, I'm pretty sure whatever the default Postgres port is.
5432.
What?
5432.
Yeah, 5432. Yeah.
Yeah, but do we have any flexibility to change the port like internal as well?
No. So one of the next things I was actually going to show was going back to the compute screen. I have the code on my other computer. I forgot to port it over. But I can probably just generate the code because it was like 5 lines anyway. So I can do a little AI action up in here. If I go here, so it doesn't give you the port because it's just using the default port. Oh yeah, you can see it in the connection string down here at the very bottom, 5432. So there's no, you can't configure it. It'll put you on to this host URL here, which is just, you know, instance, GUID, database, cloud Databricks. It'll probably be Azure Databricks if you're in Azure Databricks world. But that's, so you can't really configure the port it's on or the host name. That's all done for you by Databricks. Now, if you really wanted to, you can probably do like a reverse proxy or something to change that. But I mean, from Databricks itself, you cannot change it. So now I will show connecting to it in a second. Let's first talk about, that'll be depending on how much time I have at the end. But I mean, it's a normal Postgres server. So like my example was just going to be, it was a simple Python command that inserted 1 row into that demo table I created. And then I was going to show it in here. So it really, that can be any application. It could be Node.js, it could be Python, anything that you can connect to Postgres, you can connect to this endpoint. So let's just insert a row from here just to insert into demo table values. And we're just going to say 1 test. That's going to be our temporary row, just so we have something to replicate to the other end. So we're going to insert it. I'll just actually highlight these 2 just so we can see that it got inserted. And did I type something wrong? I probably typed something wrong there. Does anybody see what error I did here? I'm not a master at Postgres SQL, so there's probably just a little syntax I missed here. I'm going to ask the AI to fix. So let's see if it actually fixes it. I forgot to give it the schema that I wanted to use. So this was just using the built-in AI on Databricks to help me out here. So now it's that, and it got it wrong. So that shows you that AI can't do everything. But yeah, let me show replicating a Unity catalog into this. So how this works is you're going to go to whatever table you want. So let's say DB demos. Let's go this DB demos FS travel catalog. This is DB demos is like Databricks has a whole bunch of pre-built demos for you to kind of walk along, like walkthroughs basically. They'll install a bunch of data to your instance. So our Databricks instance has a whole bunch of these because we walked through them. There's this travel purchase table here. So let's say we want to replicate this to our Postgres server so that we can access it from our application. What we're going to do is we're going to click create, and then it's a little blocked off by the divider there, but we're going to use, it's called a sync table. And really all this is a pipeline which automatically moves the data for you over to Postgres without having to set up your own pipeline. So how that's going to work is it's going to be in the database that you select. So debug demo, and I made the demo 4 database. It's going to show up under the schema where this sits in. So this is sitting in the DB demos FS travel. It's going to make that schema on the Postgres server, and then whatever name I give it here. So I think this was, let's just call this travel. I don't remember what this table was called. Yeah. This is creating a Lakeflow pipeline, which is going to just read your table and push it right into Postgres for you. So it's a pre-built kind of tool from Databricks. So I can show you the code once it's actually generated. Well, it's not really much code. It's more just a YAML file. But so you basically specify everything here. You tell it the primary key for the table. This guess that it was timestamp. It's not timestamp. Let's say it's probably going to be ID. And as you can see, you can select multiple here. If you have a primary composite primary key, select that. And then there's 3 modes for transferring your data or replicating your data to your Postgres. There's snapshot, which is just move all the data right now. And if I run it again, drop that table and push all the data back in again. There's also triggered and continuous, which as you can see, this is giving me a little, it's yelling at me because this table doesn't have change data feed enabled on it, which basically just means it has like kind of a secondary location where it keeps track of all your changes as it goes through. So what that does is in triggered mode, it'll read any changes that you've done on the table since last time it ran. It'll merge those into the Postgres table every time it's ran. Continuous just means that it'll keep running in the background all the time. So as soon as there's a new change data feed available, a new like change happens, it'll instantly put, or as soon as possible, push that into the Postgres database. I don't have change data feed enabled, so I'm just gonna do a snapshot here. We're gonna create a new pipeline. Again, this is serverless again, so if you have a budget policy, you can throw it in there. And we're going to create that. And as you can see, this is what the overview looks like for this sync table. And really, this is just telling you where the data is coming from, where it's going. And if I click this pipeline ID here, this is really what it's actually doing, is it creates a pipeline for you that you can run whenever you want. So this is just like any other Lakeflow pipeline. You can set schedule if you want to. You can stop it. You can run it whenever you need to. You can create alerts off of this. So this just ran. And if I get settings, just trying to find where I can see the YAML for it. I think I'm zoomed in right now. And I always forget where that button is. I'm not used to this UI yet. I know where it is. I clicked the wrong button. It's under this 3 dots here. View settings YAML. So this is what the pipeline looks like. It's using, if you look, it's using this pre-built database table sync object that does all those work for you. So it's this pre-built object for you from Databricks to move it over. If you really wanted to, you can build your own, but this is just the nice built-in tool from Databricks to do it for you. And it does this all for you from just clicking a few buttons. So now that table, which we called, if I go back to my catalog view, we called it travel. So as you can see here in the catalog, the sync table is called travel. It sits within your Unity catalog, wherever you want it to sit. And this is more just representing that pipeline that this is being pushed to an external data or a lake-based database. So now if I go back to my query and let's select that table. So I had it under the demo 4 and that was that demo 4? Demo 4, why is this not showing what I wanted it to show? It should have a I love how I practiced this 4 times and everything goes wrong. But good thing I've done this multiple times because now I have backups. So I've done this before on some previous tables. Let me just show you what those tables are, and I can open up those previous examples that I've ran. So if I go to DB demos, let's say I copied some data from this patient readmission demo, and let me find which one it is. So I copied the visits table over. And so this is just showing, you know, everything. It's copying over the patient readmission all visits table. It's a snapshot mode. It's ran, it's completed, so it should be over on the server. So now let's check out that query. That I believe was on demo 3. And that should be, so I should see a database here called HLS, it's right behind my head, HLS patient readmission. That's the same name that it used within Unity Catalog. I do select star from visits, I'm pretty sure is what I called it. And when I query this, visits does not exist. Let me show tables. Let's see if I keep confusing Databricks SQL and Postgres SQL. Yeah, I am. Surprised this isn't working. Visits, HLS patient readmission. Anybody here know Postgres better than I do? Let me go, I have another one, demo 1. This one I copied over a fraud detection one, and let me see which one that one was. I go to fraud detection. There should be a table under here. It's a sync table. So I called one banking customer synced. If I copy this, FSI fraud detection, banking customers. All right, let's try to query this one. And this one was going to, what database did this sync to? I'm not sure. Let's see, if I go to demo 2 and HLS patient readmission, maybe it's in this one. I think I might have copied, this might be the visits table that I was looking for. I was in my wrong demo database. I should have went to the, all right. So here's the visits table copied over from Unity Catalog. This is just all the info from those visits. And if I wanted to, let me go back to this view just to kind of prove that those are the same. Here's the all visit. This was actually a view I copied over. So you can do tables, you can do views. You can only do triggered or continuous mode on tables. Everything else is snapshot only. So you can only just do an as-is copy and run that whenever you need. And let me select the compute. And in a few seconds, we should see the data here. And let me just zoom out a little bit. There it is. So we have account ID, patient ID, we have encounters. The first 3 are emergency, wellness, and wellness. If I go over to my query that I did, we should see the first 3 encounter classes are emergency, wellness, and wellness. So this is the exact same data copied over to Postgres. So that's copying data from Unity Catalog to Postgres. The other way around, I'm not going to try again because everything's been breaking on me. But I have done it before. So if I go back to the compute plane here, and go back to a Postgres, debug demo, and catalogs. As you can see, my previous attempts, I've copied over all the demo databases. So to create one, you click Create Catalog. You set the name you want it to be within Unity Catalog's top name. And then the bottom is what database on the server you want to make available within that catalog. So in my case, I already have demo, demo 2, and demo 3. Let me go to a regular SQL query. And this is Postgres SQL. Let's see if I can get out of Postgres land here. I see. So in the top left here, you can select which editor you want to go to. So I want to go to my workspace. It's a little, I keep looking at the screen and it lags a little bit. So it keeps throwing me off. All right, let's do this one. All right, here we go. So now I'm in normal Databricks SQL. As you can see, my Unity Catalog info is on the left side, and there's no Postgres SQL badge in the top right corner. So this is normal SQL. In my previous examples, I have this Postgres demo 3 table. If I click, so that's on Postgres. I made a demo 3 table just like the one I was trying to show. It has an ID, it has a comment. I inserted some data into it. and right now it's querying it, and we should see the results. And this takes a second because it's actually going to the Postgres server itself and getting the data. So there's my one test from one of my previous runs, and I just want to show this. This is going to fail because this is a read-only copy. It's going to give you this saying this is not one of the supported formats that you can insert into. So if you want to write to it, you have to do that through Postgres, but you can read the data through Unity Catalog. So I think I'm going to wrap it up there. What we went through is creating one. You saw creating a sync table to move the data from Unity Catalog to Postgres. How to create an external table to read data in Unity Catalog that's on your Postgres server. I of course misplaced my code for my demo, but it was 5 lines. You can connect to this using any Postgres SQL connector, and you can insert data and do whatever you need to do through a Postgres connector. Are there any questions or anything before I throw up the last slide? Cool. Let me find where my slideshow went. I do have one slide. You might have saw this on a little sheet by the door. We are looking to get some feedback on the user group in general. So whenever you have a second, you don't have to do it right this second. I'm going to just leave this on the screen for a bit. But before you leave, if you can scan this, and I might move it around so it doesn't get cut off by the TV screen here. Let me see if I can just fit this in like the bottom left corner.
I also have.
You have a sheet up there, right? Yeah. I'll just put this in the full screen mode, and then you can scan the sheet. But yeah, that's about my presentation. That was LakeBase on Databricks, essentially bringing full Databricks or full Postgres transaction-based databases onto the Databricks platform. And it's still really new, so that's why I wasn't super familiar with it. I have enough Postgres knowledge to query it a bit, but I'm not a master of Postgres. But it's very interesting, and especially in terms of apps and deploying things and getting things off the ground really quickly, it really helps expedite that whole process. I'll just leave it there. Thank you very much.
We do have a question online.
Yeah.
It's actually for Fred.
Nope. Do you want to go back with the computer, Fred, so they can hear you, maybe?
Is it up here on this machine as well?
It should be, yes.
Hey, Tyler, how do you get to the chat?
The chat. Go to the top. You see there's one that says "Go to" in one of the tabs. Yeah. So if you go there and then you click that little chat box there, it should show you it. There you go. Oh, there's another chat?
No, the question.
Oh, there's a questions box. I don't know.
Okay, I see. There it is.
There you go. You might just need to click on it.
So Alexander, right on top.
I'm unable to hear the voice. Okay. Oh, this looks like for Tyler. Where is this Postgres database residing?
It depends on where your Databricks is hosted. So if it's Azure, it's going to use Azure. It's all serverless, so it's actually using all Databricks compute, which I think is all AWS. I don't know the full answer on that, but it's probably documented somewhere. Yeah. You know how this webinar works.
Yep. Sorry, and mine shut down. So.
Alexander Drobek.
Yeah, there you go. That's yours.
What methods of mitigating hallucinations have you found particularly effective in these use cases? I would say it's persisting through and being very clever with the prompt engineering. So how do you do that? Creating the benchmark data set of representative questions combined with your LLM as a judge pipeline. And right now, it is, I am sure it is heading to a place where it's much more of a science. But in what you saw me describe in those projects, it was very much art. right? Grounding ourselves in any kind of truth we can find in the data. That representative benchmark set was extremely useful. And another form of control you could consider as controlling scope. So we're going to answer a certain, call it class of questions. We're not going to answer every single question anybody in the supply chain organization can dream up to ask the chatbot. We are going to narrow the scope of that chatbot to something that has enough guardrails and boundaries on it that you can shoot fish in a barrel, right? Because if you miss the fish, you hit the barrel and the water drains out, you get your fish. I hope that's helpful. Are you still online? Is that helpful?
There's a couple more questions. I was just going to look through
Oh, yeah.
the rest just to make sure we got through all the questions. Let's see.
Yeah, there's no shortage of use of just pain and suffering in problem solving. That's not a very helpful answer, but it's what it boils down to.
I think I answered this one right before Fred got up here. So I think we got through all the questions then. Cool. I will leave my last slide up for everybody online. That is your presentation. Go to my presentation and let me hit the right buttons here. Present from this slide. See, it doesn't do what I want it to do. There we go. All right, I'll leave that on for the online user, so if they want to scan it. All right, I think.
Thank you, guys.
Yeah, that wraps up.
awesome. Thank you both of
Thank you, everybody.
Thank you, everybody, for showing up.